Okay, everyone. So having now found our measures of central tendency, our arithmetic mean and our median, we can also talk about something called the mode. The mode is simply the value that appears most frequently, but the mode doesn't really tell us, the mode doesn't really have an arithmetic relationship to the rest of the data set that helps give it context in the way that the mean and the median do. So we don't tend to talk about the mode as much. So with our mean and our median, we can start to ask some more questions of our data set about the sort of relative value or position of a particular number with respect to that data set. So again, what we're looking at here is we're looking at the annual ceiling for refugees to be resettled, the annual ceiling for refugee resettlement in the US from 1980 to 2016. And we know now that the average number of the average ceiling is around 95 or 96,000. We know that the median ceiling is 80,000, right? And so the question is that if we want to talk about how much more or how much less a number is than a particular number is than those in the remainder of the data set, right? So this is going to let us understand how extreme is a particular value, right? Or how close to normal is it? We can't do that kind of thing heuristically. In other words, I can't just say, well, 50,000 sounds like a lot less than 80,000, right? Okay, well, it's, 30,000 different. But, the median, for example, doesn't really take into account what the other values are, right? So we can see that the top value is almost 232,000. The bottom value, as it happens, is 67,000. So that might give us an indication, right? We can see very quickly, okay, 50,000 is less than any ceiling since 1980, so that's something that we could say. But we can say even more. We can understand better how a particular figure fits into this context if we look at the measures of spread. So the quote-unquote measure of spread is basically saying how are the numbers clustered within a particular data set. And to kind of demonstrate this is actually something that's much easier to think about visually, I feel. And so I want to show you, we're going to actually look up, so the measure of spread with respect to the arithmetic mean. So these two things are measuring, they're both measures of central tendency. They apply in different situations. We're going to start by calculating them, and then we're going to talk about how to determine when to use each one. So the measure of central tendency that goes along with the arithmetic mean is called the standard deviation. And this may be a term that some of you have heard before. It may not be. Either way is fine. And then with median, we tend to talk about something called the upper bound and the lower bound, okay? And we get to the upper bound and the lower bound first. There are multiple steps to calculating each of these kinds of sets of parameters. But I want to first show you kind of what they represent. So I'm literally just going to Google standard deviation here. Wikipedia actually has some great visuals for these things, so I recommend checking it out. It's a helpful reference to keep around. So the mean is, and I like this graphic better because it helps us understand why something like the standard deviation is important, right? Because we can't say, so this is an example of two data sets, both of which have an average, an arithmetic mean of 50. But the red data set, as you can see, doesn't have a very broad standard deviation. In other words, that value, in this case the average value is 100, but all of the data points are clustered very, very close to that value of 100. In the second data set, the blue data set, we see it also has an arithmetic mean, right? Add them up and divide them, of 100, but the standard deviation is 50. It is much more spread out, right? And so this is precisely the reason why we cannot judge whether a particular number is extreme simply by saying, oh, it's really far from the center, right? Because, something could be very far from the center in this blue data set, but actually still be within what we think of as the realm of normal. And the reason for that is that for a normal distribution, we talk about where the majority, for both sets of distributions, and for both types of measures, we talk about how much of the data set falls within a certain distance from the measure of central tendency. So this is a mean. Each one of these, I think it's the lowercase sigma, I always forget. Each one of these represents a standard deviation. And what this graphic is showing us is that 68.2% of all of the values in a given data set fall within, in a given data set where we're looking at the mean, fall within one standard deviation of that mean, okay? So what does that mean? When we think about it, when we think about extremity, we're saying, well, this is really unusual, right? This is different than most of the numbers in the data set. We don't tend to think of things as being really extreme unless they're over 3 standard deviations from the mean in either direction, right? We can see it can be much greater or much smaller, obviously. But the question is, how far away is it from that mean? And so in this case, for the standard deviation, we have an arithmetic mean of 96,000 or so. In fact, I would probably round this to 96,000 before reporting it. So the question is, what is a standard deviation, right? How far away from that mean, how far away from that mean is like really far away, basically. So I guess I'll let you all shortcut this because data analysis is not the focus of this class. I will point out that it is important to know, it's worth knowing how this formula is constructed. But basically, the standard deviation, I can actually use this. This is, formula. It's going to be, we're going to use I can use STDP here. Okay, so this is one of the things that's confusing, right? Which is like, which one do I use? So basically what this is saying is the standard deviation of, quote, a population, which means that basically I have measured all the things. STDev.S means it's a standard deviation of a sample, right? It's not all of them. In this case, if we were to write our story talking about the number of the refugee resettlement ceiling since 1980, we would be talking about the entire universe, the entire data set. So in this case, I can go ahead and select all these numbers, and Excel is going to do some work in the background. And it's going to come up with this, again, much too long number, right? Because you can see it's calculating this to 5 decimal places. That's way too much. For my own visual clarity, I'm going to go ahead and knock this down to 0 decimal places. In the background, if I do further calculations on this, then Excel will still use, again, the precise number to do those calculations. But visually, I can see this as about around 38,000, right? So now this starts to make a little bit more sense, right? Because if we go back to our visual, what we can see is, well, okay, something that is 1 standard deviation away from the mean, either positive or negative, is, well, anything that falls within that is like most of the data. So the question is, if I have a value of 50,000, how many standard deviations away from the mean is that? So this is what we call a z-score, or an index score, but basically it is the number that corresponds to the point on this number line, right? So if we think of the x-axis as a number of standard deviations, it sort of has a midline here, and we say, okay, is the z-score 1 or -1, which would represent 1 standard deviation? Is it -2, which would represent 2 standard deviations, and so on and so forth? And obviously we can calculate this to a decimal point. What that lets us know is how far away from the center is this. So I'm going to go ahead and do that. And so what I can do for each value here is I can say, what is the z-score for this value? And if I want to, I can actually, well, I think the easiest way to do this for our for our prospective number of 50,000, the question is, if the standard deviation is 37,866, how far away from the mean, how many standard deviations away from the mean is 50,000? So the first thing that we can do is difference between mean and target. Okay, so that's going to be 50,000. Right, so 50,000 is the number that we're curious about, and we're going to say, all right, if we take its difference from the mean, how much is that? So it's 45,000, around 46,000 difference from the mean. And then I'm going to say, well, how many standard deviations is that, right? How many standard deviations does 45,000 represent? We're kind of in a non-unit thing here. That's one of the things to look at, is that because we do the division, we sort of lose the units. These become that the z-score is literally just, it's a number. It's really a number of standard deviations. And so we can say the z-score of 50,000, of a value of 50,000, is going to be whatever this difference is divided by the value of the standard deviation. And in this case, I do want to, where's format cells? Oh, there we go. I do want to go to like 1 decimal point just to see. But you can see right away that actually 50,000 isn't that far from the norm. Because again, if we were to say, if we were to look back at this figure, what we know is that, well, you know, actually, what is it, 90, yes, it's the 95, 99.7 rule. 95% of the values are somewhere in that range, right? This isn't a huge deviation. We could explore how different, for example, this 231 was, right? Like, how extreme was that? So I'm going to go ahead and insert another row here, and I'm going to say, just call this for 231.7, right? Which was, well, for 1980, really. That's the meaningful thing. And this is, so in that case, I'm going to say, okay, I'm going to take this number, I'm going to subtract the mean, right? And I can do this all in one line. I can divide by the standard deviation. Whoops, that didn't work. This is where our order of operations matters, right? And I get 3.6. Now here's the trick. Once upon a time, the US admitted we had a ceiling of almost 232,000 refugees. That is extremely unusual in the last 35 years. If we look at it, in fact, remember that anything over 3 is highly unusual. It is different than 99.7% of all of the other values that are here. So what we can see is, yes, once upon a time, we had a ceiling of almost 232,000. That was a strong aberration, not just in the history of refugee ceilings. So what we're trying to do here is we're trying to get a sense of how unusual is a given value. And in this case, we can see that the z-score for 2017, as it stands, is actually only negative 1.2. The z-score for 1980 was 3.6. Although this may seem unusual, the fact is it's actually not that atypical. So the next thing that we're going to look at is going to be these this measure of spread with respect to the median. Okay, and the reason why is that sometimes it's appropriate to use the mean, and sometimes it's not appropriate to use the mean. So once we finish going over these upper bound and lower bound, or both sets of spread, we'll talk about how to know when to use each one.